Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to see how we can implement logistic regression and we can implement, the confusion metrics, the cross validation, evaluation, how we can evaluate the model, setting up parameter grid and hyperparameter tuning. So all these parts we are going to see in this particular video. In my previous video, I have already shown you how we can implement logistic regression, and now here we are going to see how we can evaluate our model and how we can tune our model. So this is what we are going to see in this particular video, but do remember to watch all my previous videos, because the concept of what is confusion metrics, what is cross validation, how basically what is a parameter grid, the hyperparameters part. So all of this I have explained in all of my previous videos, theoretical videos, and which is very important in order to understand this, right? So let's move ahead, and even before moving ahead, I do recommend all of you to subscribe to my channel, connect with me on LinkedIn as well, and I will leave the link in the description box. So let's move ahead and see exactly what we have for today. So now if you see till here, right, I have already explained in my past video, in my last video I have already explained that we have read iris data set, and we have applied logistic regression, multi-class logistic regression, right, on the iris data set, and this was our data set: sepal length, sepal width, petal width, id, and these were the species that we were trying to classify. So this is what all we have done, and we have also created these features. We have vectorized our features, right? We have seen all of this in our previous video. So this is the feature vector, and then we have also scaled our feature. This is how we have done this is how we have implemented the scaling in our past videos from 0 to 1, and after that we have also done the prediction, and these are the prediction outputs, right? 0, 1, 2, and the species which are predicted are Setosa versicolor. All these things I have explained in my previous video, right? So now let's start with the confusion metrics part, right? Now if I go back to my slides over here, so whenever we talk about confusion metrics, right, so if you see, this is what I have explained in my past videos, right? So these are all my past videos in the playlist, cross validation, mean squared error, confusion metrics, performance metric, elastic net regression. So all these terms I'm going to use in this video as well. So if you want to understand the details, do watch out these videos. So now when you talk about confusion metrics, what it actually does, it summarizes the performance of your machine learning model, right? So that is what we have to do. Now this is how my model has predicted. These are the species that my model has predicted on my test data set, right? But now what is my model performance? How I'm going to evaluate it? I can evaluate it using confusion metrics. Right now here in this command 32, you can actually see what I have done over here. I have created confusion metrics manually, right? This is how we can do it manually, right? Is it that we have to all the time we have to calculate it manually? No, that's not the case, but I'm showing you all possible ways right now. So to evaluate the performance of your model, I can actually go ahead and create confusion metrics, right? This is the same confusion metrics that I have explained to you, right? So now if you see at the top, right, Virginica, versicolor, and Setosa, these are my predicted outputs, and iris virginica, versicolor, iris setosa, these are my actual outputs, right? So iris virginica, these are my actual output, right? How many of iris virginica, those were actual, and they were also predicted as virginica, total 8, right? So like that, basically we kind of you can see that we have created a confusion matrix over here, right, using the pivot. So this is how you can actually use confusion metrics as well in case you want to understand the performance. Now using this confusion metrics, you can get your true positives, true negatives, and things like that, right, what we have discussed earlier. So now if you want to plot your confusion metrics, you can do that. You can use any library, right? Here I have used Seaborn, right? Now if you see over here, the same thing what I was showing you diagram as a tabular format over here, you can actually see that I am showing you the same values diagrammatically over here, right? So how many of iris virginica, which are the true values, were also predicted as virginica? 8, right? How many versicolor were predicted very correctly, right? So these if you see 8, how many of Setosa were actually predicted as Setosa 5. So this is how you can actually see the this is how you can actually see the cross validation output as well in a diagrammatical format. Now similarly, let's talk about how we can evaluate our model. Right now, when I say evaluate our model, so right now whatever you have done, you have actually created your confusion matrix manually over here, and then you have diagrammatically displayed it. But now if you see, my model was this pipeline model at the top that I created, right? So if I go at the top, I have created this pipeline model, right? If you see over here, this was my pipeline model that was created, right? Now how did my model perform? Right, when I have created this model, when I fit this particular model, if you see at the top, this is the pipeline model that I have created. I have trained it on my training data set, and I have got the pipeline model. Now if I want to evaluate the performance of my model, right, what I can actually do over here is I can use model.evaluate. Evaluate is used to evaluate your model. Evaluate is actually used to evaluate your model. Now if you see, basically I am saying model.evaluate, right, and evaluate on the results. Check how is my model, what is the recall, what is the precision, what are the false positive rate, how is my model performing with my result data set. So results dot, so from this results data set that I have got at the top over here, right, what I am doing, I am taking in the two values, features underscore scaled. I am giving it the input features, as well as I am giving it the species underscore a, right? I am giving it the input. Right now with that, I am asking my model, I am trying to get the metrics out of it, right? How is my model going to behave? Now after I get this metrics, right, I can actually simply say metrics dot recall by label, metrics dot precision by label, metrics dot false positive rate by label, 1 minus metrics false positive rate by label. So this is another way in which you can actually evaluate your model. Now if you do that, you will actually know that okay, the sensitivity of your model is nothing but 0.8, right? The precision is 1. So like that, you can actually evaluate your model. Now guys, you are not going to understand any of these what I am saying right now if you have not watched all of these videos. So these are very important to understand. It's very important to go through all of these videos in order to understand what I am saying right now. So similarly, basically you can this is how you can evaluate your model as well in PySpark without trying to build confusion matrix manually, right? So you can get all your true positives, true negative rate, everything over here you can get it. Now similarly, let's talk about cross validation and hyperparameter tuning. So now till here I have just talked about evaluating the model, the confusion matrix part of it. First we build the confusion matrix, and we try to understand what are the number of true positives, true negatives, have we achieved it or not, so things like that. But now cross validation and hyperparameter tuning, it means whether our model is actually performing well or not, how well our model is performing. So tuning the parameters of the model, right? This is also we have talked about in our previous videos. Now to do cross validation and hyperparameter tuning, right, let's start with this creating parameter grid. So when I say creating parameter grid, so first of all from pyspark.ml.tuning you have to import cross validator and parameter grid builder. So what exactly is this about? So if you look at this parameter grid builder, right, so this basically helps you to set few parameters which your model will perform cross validation on. So what is going to happen is, in case of cross validations, right, I have already talked about cross validation. So this is one type of cross validation, right? So basically your training data set, right, will be divided into validation and the training data set. So each time your validation data set will be a one block, right, and then you are going to calculate the errors that are coming in each of these iteration, and then you are going to get the average of that particular error, and whichever parameters gives you the less amount of error, that is basically the best set of hyperparameters, or that is basically called as your hyperparameter tuning, right? So in the similar case over here, this parameter grid builder helps you to select few parameters. So for example, let's talk about param grid builder, lr dot logistic regression model dot elastic net param, right? Regression param. So elastic net param, this again I have talked about this earlier, so in this particular video, elastic net regression, right? So basically in elastic net regression we are setting up these parameter 0, 0.5 and 1. So these are the three values that we put in our elastic net param, right? So whether we are trying to achieve L1 regularization or L2 regularization, right, that is defined by this elastic net param, right? So that is why I say watching the previous video is very important. So elastic net param, if you see over here, right, this is nothing but in our lasso and ridge algorithm, right, we put lambda beta j hat, right, or beta j of square. This is what we put, right? So similar thing over here in elastic net param basically defines whether you are using a lasso algorithm or you are giving more importance to the ridge or you are giving equal importance to both of them, right? So that is what your elastic net param is. So first of all we define our elastic net param, and then we also put over here our regularization param. Now this regularization param is nothing but the lambda that you put, right? This is the value of the lambda. Now these are nothing, these two are nothing but this regression param is nothing but it is our hyperparameter, right? That is the value of this lambda, right? So elastic net param basically defines whether you want lasso algorithm or you want the ridge algorithm, right? This lambda is nothing but your hyperparameter. So here what I am trying to do, I am trying to put different values of lambda. I am trying to put different values of lambda, right, over here 0 and 0.1, right? And similarly I am putting feature assembler and the columns combination. If you see, so these are feature assembler dot input column. So I am saying take these as my input features, right? So this is nothing but this is my input features. Now column combination. Now hyperparameter can be decided based on number of column combinations. So if you see over here, right, maybe these two columns sepal length and sepal width are the more important columns in creating my best hyperparameters, or maybe all four of them are important, or maybe three of them are important. So like this we try to create different combinations of columns. So this is what this combination is. So this is what we are trying to achieve in a command 39. So we are trying to, so we have four columns, right, sepal length, sepal width, petal length and petal width. So we are trying to create combinations of these and we are trying to pass it to our parameter grid. So we are saying that for these different combinations of input columns, use this as my regression parameter, use this as my lambda values, use this as my elastic net param, right? Try to check whether lasso will suit it best or ridge will suit best or both of them will suit best, right? So it tries to do all the cross validation over here, and after that it is going to give you the best parameters from it. So that is what is called your parameter grid. So similarly, once you have defined this, right, what I am trying to do now, even to evaluate the performance of my model, basically I have to define a metric, right? So now I understand that this is the parameters that I have given, but I want to evaluate my model based on what? Do I want to check its accuracy? Do I want to check its F1 score? What do I want to check it, right? So for that you can actually use from PySpark.ml.evaluation import regression evaluator and multi-class classification evaluator. So since it is a multi-class problem that we are trying to solve, we use this multi-class classification evaluator and we say that this is our label column, this is our prediction column, we will name it as prediction, and we have to check the accuracy. So this becomes our evaluator. So we have to evaluate our model based on this matrix, which is nothing but the accuracy, right? So basically here we are just saying that we want to evaluate our model based on this accuracy. So if we want to evaluate anything, right, then in that case we can actually use this evaluator. So what will happen is, whatever data set that we pass to this evaluator, it is going to evaluate the accuracy and it is then going to give us the result. So now let's skip command number 44 at this point and let's go to command 45. Now in this case we have also imported cross validator at the top, right? If you see over here, we have also imported from PySpark.ml.tuning import cross validator, right? So we have built the parameter grid, right, and we have also mentioned our evaluator that we want to evaluate the accuracy. We want to evaluate the best model based on its accuracy. What is accuracy? I've already explained it, right, in my performance metrics, as in my performance metrics video. Now, using this cross validator, I am going to check what are my hyperparameter. Now this is the cross validator that is going to evaluate my whole set of parameters that I have provided in my param grid. Right now, if you go to the cross validator, estimator is the pipeline. Now if you look at this pipeline, right, this is the same pipeline that we have created at the top. So if I go over here, right, this is the pipeline that I have explained in my previous video, that this is the pipeline which is created, which takes in the steps that needs to be performed as the part of logistic regression. So if I go back, right, if I go back over here, you can actually see that this is the pipeline as one. This is taking pipeline as one of the parameter. Then it is taking parameter grid, right? The parameter grid, that is what I have explained you at the top, right? These are the parameters that it is taking. Now after taking this parameter, and then it is also taking evaluator, right? Okay, I have given all my I have given my pipeline steps, I have given my parameter grid, I have also given my evaluator that evaluate it based on accuracy. Number of folds 3, right? So now if I go back, right, if I go back, I have already explained this number of folds, right? The number of iterations is nothing but that is called the number of folds. So if you see here, number of folds are 5, right, but I have mentioned over here number of folds as 3, right? And collect some models true, right? So whatever models will be created as part of this cross validation, right, those will be stored in Databricks, right? If you perform this same operation on any other tool, let's say Jupyter Notebooks or anything, then in that case it's not possible, but in Databricks it's possible. You actually store your models as well, about which we are going to cover in upcoming videos. So if you see, this is nothing but your hyperparameter tuning. So what you are trying to do, so all your model, all the logistic regression model in the pipeline, that will run for different combination of these parameter grids, and it is going to evaluate the accuracy with number of folds equal to 3. This is what is going to happen. Now the cross validator ran. Now after that, what you can do, you can simply say cv.fit_train. So what is fit going to do? Fit is going to train your model, right, basically. So it is going to train your model on the training data set. This train is nothing but the training data set, right? So we created this training data set at the top, right? So if you see the test and the training data, train and test. So we use random split to split our training and testing data. The same thing happened over here. So we are trying, using this cross validator, whatever model came as the best model for us, just fit that model based on the training data set. And then if you want to actually see the performance, how did that model perform and what are the parameters that model used, so you can actually see it. You can simply say cv_model, the model that you got from here, cv.model.best model. So you will see, you know, you will actually get your best model over here, and from best model dot stages, right, I'm fetching the 0th index and then get input columns. So what are the input columns that were used to create this best model? These two. So using these two input features, using these two columns itself, my best model was created. What is the elastic net parameter that was used? 0.5 that was used. So we have provided 3 elastic net params, right? So here you can see out of those 3.5 was used. What is the regression parameter? It is 0.1. So using these values, using this hyperparameter, using these values, my best model was created. So this is how you can actually train your model on the best hyperparameters, right? And in case of Databricks, it is actually saving your output models as well, right? If it is creating 10 models in your cross validation, it is storing all those 10 models. Now similarly, evaluator, right? So just I skipped this particular command to explain you in the end. So if you see this evaluator, right, inside this evaluator, you can actually say evaluator.evaluate, right, whatever you want to evaluate. So if you want to evaluate the results, right, so results is nothing but the results that we got as output of our first model run, right? So those were nothing but those were the results. So evaluator.evaluate results, evaluator.metric name, evaluate the accuracy. So if you want to get the accuracy of that model, you can get it like this. If you want to get the F1 score of a model, you can get it like this. If you want to get the precision or recall, you can get it like this. So you can see the accuracy was 0.9, F1 score was 0.9, and these are the different other values as well, right? Precision, recall, and accuracy. So you got this. So this is also one of the way. So I hope you understood what I was trying to explain in this whole video, right? So first of all, what I showed you is confusion matrix, that you can compute your confusion matrix manually as well. So we computed our confusion matrix over here manually. Over here we plotted our confusion matrix as well, then we evaluated the model, right? Whatever model that we got at the top, right? So we tried to evaluate that model as well. So we got our precision, recall values using the matrix, right? So model.evaluate will help you get the different metrics. Similarly, we also created for the cross validation and hyperparameter tuning, we created parameter grid which takes in your values. It tries to put multiple combinations, right, for all of your elastic. So first it will create your model for this particular elastic net 0.0 and regression param 0.0 and the different combinations of input columns. It will try to create multiple models. Out of that, whatever model you have defined, whatever accuracy metric that whatever metric name you have defined, here it is accuracy. So based on this evaluator, it is going to basically check, this cross validator is going to check which is your best model, what is your best model, and then you can use that model to train your data. You can get the best model over here. So CV model is the best model, and then if I want, I can simply say cv.best model to get my best model, and then whatever the parameters were used during the creation of this best model, that you can get it over here. So this is nothing but it is your hyperparameter tuning in case of logistic regression. So I hope you guys like this particular video. If you did not understand it, I do recommend watching my playlist one by one. If you do not understand in one go, you have to make an effort to understand these videos again, right? So I hope you like this particular video. Do remember to like, share and subscribe, because this takes a lot of effort, especially in creating such videos which are very I would say not very engaging per se, because these are not very engaging videos. These are concepts which are not very easy to understand either. So I hope you like this video, and do remember to like, share and subscribe to my channel.